We are going to work on graphing from the vertex form of an equation. The first thing that I want to do here is I want to find the zeros of this equation. To do that, I'm going to set this y value equal to 0. And now I'm going to think about the order of operations. I am going to undo steps in reverse order so I can find the value of x. Looking at this side, if I think about the order of operations, the very last step in the order of operations would be to add this 9. In order to get rid of adding 9, I am going to subtract 9 from both sides. And now I have negative 9 equals negative 1 times x minus 4 squared. I'm going to think again about what would be the last step in the order of operations over here. Well, the very last step over here would be to times by negative 1. So I'm going to undo times by negative 1 by dividing by negative 1. My new equation, 9 equals x minus 4 squared. Again, I need to think about what is that last step in the order of operations. Here it would be undoing the exponent. The exponent was the last thing. To undo an exponent of 2, I can square root both sides. Recall that when I take a square root of a number, I can get two answers. I can get a positive answer and a negative answer. So here I find that the square root of 9 is either positive 3, which equals x minus 4, or the square root of 9 is negative 3, which equals x minus 4. If I'm solving this first equation, I need to undo subtracting 4. I'm going to add 4 to both sides, and 7 equals x. Looking at the second equation, undoing the subtract 4, I'm going to add 4 to both sides. My result, 1 equals x. My two zeros are 7, 0 and 1, 0. We're going to work on our y-intercept next. Recall that with a y-intercept, the value of x is 0. I'm going to go into this equation and replace x with 0 so I can find y. I will plug this into my calculator, and when I do that, my calculator gives me y equals negative 7. Recall that the y-intercept is 0, y. So this is 0, negative 7. Now we're going to work on our axis of symmetry, our vertex, and our, in this case, maximum. It's a maximum because our a value is negative. It will be easiest to start right now on the vertex. Recall from our function unit that when I look at this, I will look inside of the parentheses to determine if I've moved left or right. I will look outside the parentheses to determine if I've moved up or down. A negative in parentheses feels backwards. It moves me in the positive direction. It moves me to the right 4. The number on the outside feels normal. It moves me in the positive direction. It moves me up 9. So I went to the right 4, up 9. I have a vertex of 4, 9. Recall that our axis of symmetry is an x equal line that has the same value as the x value of our vertex. So this is an x equal 4 line. And our maximum here is going to be the y value of the vertex. So our maximum is going to be at 9. I am going to use the information that we have just discovered in order to make a graph. My first zero is at 7, 0, right here. My second zero is at 1, 0. Coming down here, I have a y-intercept of 0, negative 7. I have an axis of symmetry at x equals 4. This is that guiding line that helps me to make sure that when I draw my parabola, that it looks like a mirror reflection. I have a vertex at 4, 9, right up here. Before I draw my U shape, I'm going to go back down here to where I graphed the y-intercept. I want to get the mirror reflection of that over here on this side of my axis of symmetry. I see that it is 4 spaces from my y-intercept to the axis of symmetry. So I'm going to go 4 spaces on the other side of the axis of symmetry and make my dot at the same level. I'm going to use these dots now to guide me as I draw my U shape. Let me try drawing that again. There's that half. If I go back up, there we have our 2 halves of the parabola that look like mirror reflections.